Okay. Hello, good morning. I'm Alan. I'm from ADLINK Product Manager. So I'm going to introduce our Swarm Atomic solution. So in a smart factory. Okay. So I will go through this to the top here. Okay. So this agenda here, I will go through like the atomic solution and this kind of the factory. Want to have the transfer, how the transfer phase out, and with offering the feature, the advantage, blah blah blah, and the benefit of the market. Okay. So this is the best one. In the past, our company is focused on the automatic. So we just focus on like the A motion control, B motion vision, IO sensing, AI, AOI. Lots of things is in the factory. So the machine is automatic. So in the past we focus on this one, right? But nowadays, try to image that if the machine can talk each other. Okay. So we call the swarm autonomy. Okay. Swarm autonomy for our concepts that we try to make the machine talk each other. So how can they do that? You can know in the factory, no matter old one or new one, the AMR is a physical machine can go through into the factory everywhere. So if the message can bring by themselves, so I can bring the message to one machine to another machine or maybe the third machine. Okay. So here I will say that we try to make our factory from automatic to autonomy. So the AMR is quite the physical things here we provide. And the AMR can communication with the machine or maybe OT level, IT level. So IT level is like ERP, OT level like all the machine in the factory. They can communicate by themselves. So you will reduce the labor. And also they will optimize production efficiency. Okay, with the autonomic mobile series. So this is a very simple concept about autonomy. So the next I will go to talk about the challenge. If like the factory want to transfer the automated autonomy, what kind of challenges we can face? So put it simply, there are two challenges we sum up. Okay, the first is the difficult in developing integration. Another one is the complicated operation process. Okay, so the first here we can see in the factory, no matter new one or the old one, legacy one, so there are lots of machines, right? And the machine they will come with the multi-brand, and the multi-brand have their own systems. And I just mentioned that swarm autonomy need to combine with OT level and the IT level, so you can image that. So lots of the different brand, different system, so it's really hard to integrate or to combine with every system. Okay, and based on this one, the complete operating process like that. So the old systems like we have the lots of AMR brand, right? So each brand they have their own robot control systems, and the IT level maybe we have a warehouse control systems, maybe ERP, lots of systems, and the systems is all nowadays lots of factories all controlled by the operator or workers. So the machine, the information or data is a synchronized communication beyond this. So these two things is kind of a challenge. We talk to the factory owner. They try to transfer their type from automated to autonomy. So the offering here, we offer two kind of product here. Okay, one is AMR, just I mentioned, is a physical things goes to factory everywhere. So we provide AMR, and we call SMR here. The S means the swarm. Okay, so we try to name our AMR names called SMR. So another is one core. AMR we provide two kinds of payload, 100 kilograms and 250 kilograms. It depends on the different scenario because you take like maybe you have a robot conveyor or maybe you have the big rocker, small one. So different payload, you can use the different SMR. Okay. So another is the Swarm core. Swarm core is just a software. You can image just the operating systems. So Swarm core just a software. We just put the Swarm core into the server. So it's like edge controller, like PC, computer, server, everything, just computer. And the Swarm core, what is Swarm core doing? Swarm core try to make the user easier configure the machine and operating the monitor. And the Swarm core, we have two kinds of feature here. One is going to combine the old machine, and another is we have our dispatching systems. Okay. Okay, next I will go to have two feature about these two products, and I'll try to use the feature to give more detail about the autonomy, what we can do. Okay. So Swarm core, one of the features is heterogeneous integration. Okay, heterogeneous integration. So just as I mentioned, in the, this is a factory, right? So in the factory OT side, we can see normally in the factory, we have the, our AMR here. And maybe the factory, the legacy one, they have their own third-party AMR. And then maybe in the factory, we have the device, third-party device, like elevator, like PLC, like rack storage. So each device here. And also we have a third-party top modules. Just as I say, the AMR has a different function. So maybe one function is like combined with conveyor, maybe combined with a robot. So AMR will take a robot to go where they go to pick up or drop off the things, right? So it's the OT side. Normally we just separate it into this product line, okay? Then IT side, quite easy. Third-party IT systems like MES, ERP, depends on the factory owner what they have. Okay, maybe, ERP and MES is quite common things to see in a factory. Okay, so what the Swarm code doing? Okay, Swarm code, we provide the Swarm protocol. You can see Swarm protocol, we try to unify the communication. So Swarm protocol just like a highway, just a highway. So the highway is here in the factory. So we try to make each component to connect with the highway. So basically, our AMR, we just already integrate inside. So already integrate in our Swarm core. So our AMR is quite, no need to do anything, just connect to the Swarm protocol. And the Swarm protocol will deliver the message or data in time and synchronously. And how about IT systems? I mean, the IT system, we provide the Swarm Core API. Swarm Core API is kind of CK, which means that if the ERP system, no matter big or small one, you can modify by yourself. You can just directly use the API, so you don't need to do everything to do the transfer. So Swarm API will connect with the IT system to Swarm Core. So basically, we can see that if the ERP system send a message from the IT system, send a mission to the Swarm Core, and the Swarm Core will dispatch in the AMR to do the things. So try to image that everything will go to the Swarm protocol and make the data and the image information synchronously. And how about third-party device? As you know, third-party device has their own protocol. Like maybe the robot have the Ethernet bus, or maybe OPC and the Profinet, lots of protocol worldwide, right? So about this kind of the third-party top module, and also have the third-party IT systems. This third-party is like, because some IT systems are quite big, and you don't have the access to directly modify the core in the third-party IT system. So for this kind of third-party, no matter IT system or OT system, we provide another tool, and we call Swarm Reaper. Okay, so Swarm Reaper is kind of the SDK. SDK try to connect the third party through their protocol, and SDK just like we try to make it very easily. Okay, so I will introduce later. Okay, so the Swarm Core one feature is going to about the heterogeneous integration. So we provide the Swarm Core wrapper and the Swarm API, and try to make the machine in the factory connect to our Swarm protocol and try to make all the information or data, go through very in time and synchronized, have the communication here. So this is a Swarm Core one benefit and one feature here. And by the way, so as you know, in the factory, we try to make the data connect together, right? So maybe we use the Wi-Fi, Wi-Fi internet to make each machine goes to Wi-Fi side. And our AMR also provide a private 5G. Okay, private 5G is another trend of the factory. Okay, so our company is going to provide like a private 5G servers. So our AMR, definitely we will support the private 5G protocol here, right? Okay, so this is one of the Swarm Core the feature. Another is going to, I just mentioned our Swarm Core have the dispatching system, which means like a fleet management. So the dispatching system, we use the event-based control. Event-based like ERP will send the mission one, like mission one means like maybe, hey, AMR will go from machine A to machine B or machine B to machine C. So each machine will define to event-based. So we use this kind of event-based control management, and we have our dynamic reschedule capability. So I will give you like 3 scenarios on the right-hand side. Yeah, on the right-hand side, 2 scenarios to put it simply how it works. Okay. So for the first one here, we can see there's a factory and there's a cargo here. So the ERP will send a message to our Swan code. So Swan code will very similarly to ask one of AMA to pick up. Okay, so that's very easy. Another scenario is that there's another cargo here. Another cargo here. So actually, yeah, it's the same. So our Swan code will get the command, get the mission from ERP, and another AMA comes. Okay, but if something happened on the road here, maybe some obstacle here happen, something is here, so it stopped the AMA the way to the cargo. We have the timeout. So you can set our timeout you can set out 5 seconds, 10 minutes, 30 minutes. So if you're counting down, and then maybe the operator cannot handle this kind of the situation, the AMA will go to another way. So we call our backup road. This AMA will go to another way to pick up the cargo to finish the mission. So we call it dynamic resource capability. Okay. So the third scenario is here. Just like if the situation stay here and the third AMA comes to want to go this way, but our Swan code will talk to the third one and talk to him, say, oh no, we cannot go this way. So they will pick up another way. So we call the traffic control. Okay. So these three scenarios going to describe our dispatching systems. So we try to make the material waiting time to make them no need to time to wait. Okay, so our Swan code will automatically to decide which AMA goes to pick up and which AMA to go to another way to avoid this kind of things. And just as I say, Swan code will have this kind of supervisor. So we try to make the labor, make the operator to have the less fleet supervisor. Okay, so this all the things is automatic run our Swan code. Okay, so these two features about Swan code, and I think these two features are very simple to understand and try to image everything must go to the Swan autonomy, so make every equipment can talk to each other by this way. Okay, so I will say another advantage of our Swan code, because in the factory, I think we try to make the device or maybe use the UI or method one simple. It's quite good, right? So what our UI provide, the first thing is that our UI provide the agent info. You can see the middle one is our AMR, right? So this is a real case in Taiwan. So we just integrate the third-party AMR here and the other third-party AMR here. So you can see from this UI, you can manage all the devices you have already integrated into the Swan core. Okay, so the top here, we can see there's a conveyor, elevator, top modules. It's kind of third-party device. It's not a robot. It's not a car, right? So this kind of third-party, we use the Swan wrapper here. So you can see we have a wrapper A, just combined with the conveyor. Wrapper B, which is already connected with the PLC in elevator. So the Swan code can control the PLC, ask the elevator to open the door, and AMR goes through, and go down, go up. Okay. Also top module as well. So this is info. And right now our wrappers use the Python to modify, but in the Gene we will provide the UI, only UI. So the user, the system integrator just use a click. They were easier to connect the supply device into Swan core. Okay. So the next one is real-time monitor. In this Swan core, the UI also provide a real-time monitor to check, okay, how is the situation, how is the things in factory here, so we can see where is AMR and where is the AMR, what happened. So it's a real-time monitoring. And the third one is workflow operation. Just like I said, it's more complicated here. Because the AMR, we don't have a symbol, which means that Swan code will automatically decide which AMR will pick up the missions, right? So in the Swan code, we need to define the simplest workflow, like point A to point B, okay? So this our code is one workflow. So we need to define the workflow operation in this UI. So it's very pretty simple, like you just put out what the command you want to give the AMR. So the Swan code will know which AMR need to use a different workflow, okay? Okay, and the last one is the state management. So in the factory, we will show how the AMR works now, and everything will have the data here, so user can easily to see what they want to see, the status management here. Okay, so we try to put everything into one software, our Swan code, and try to make user easier to connect, no matter the third party or the our solutions here. Okay, so this is all Swan code. The next is about the SMR, physical things. So this page is easy to understand. So about the physical things, SMR, we have our experiment. Our docking performance right now is plus and minus 5 millimeters. So compared to tier 1, another brand company, I think it's nearly the same performance here. So it's make you can use this SMR to maybe more critical environment here. Okay. So another is about another is the dynamic parameter zone setup. This is related to the safety. Okay, the SMR goes to the factory about the safety. So I will go to explain two. One is here. Yeah, you can see the circle line, the blue circle with the blue line. This is our SMR. Just imagine this SMR, our car, and the red one and the yellow one is a safety distance, which means that if the SMR goes through and something in front of him, into the yellow distance, yellow area, they will slow down, and into the red one, they will stop. So it's quite understand. I think each area have this kind of function, right? But we have the two scenarios. Just as I mentioned, our MR can combine with the top module, right? So the scenario one is here. Here, this is a conveyor, right? The top module conveyor. I use conveyor to make as an example. So you can see conveyor is bigger than our AMR. So I just combine with the conveyor with our AMR, and we need to set up the step distance change. Okay, so the AMR knows like how safety distance far they need to know. So if we go to the factory, they need to know, oh, I can go this way. This is quite small. I need to go another way. Okay, so this is top module here. Try to make it's about safety, more safety. Another scenario 2 is about rock. I say SMR in factory. Okay, sorry. SMR in a factory has two different kinds of usage, right? So one is combined with the top module, another is combined with the rack. Rack means that rack is everywhere in the factory. So our SMR can lift on the rack, one of rack to another way and put down, and it goes to pick up another rack. So as you know, rack is has different size in a factory. So we can set our rack size in Swan code. And just as I mentioned, our AMR is automatically assigned by Swan code. So the AMR 1 maybe goes to rack 1, they will dynamically change the safety zone, okay, to make sure the safety zone is changed. And if we go to the small one like rack 2, they will be smaller. So this is the safety zone change depends on top module or rack. Okay. So the next one is the must be setting in different area. This is the real case in Taiwan, right? So you can see the area 1, each machine is not close. It's not close. And compared to area 2, the machine, the machine is a blue circle. So each machine is quite close, right? So we can set up the area 1 define like the small, which means that no matter which AMR goes into area 1, they will use the max speed like 1.5. But if we go to area 2, we can set out like a bigger one. And so which AMR goes to here, they just use like 0.6, the limit. They will have the restriction of AMR speed. Try to make AMR more safety in the factory. Okay? So these two things dynamically parameter zone our SMR in our AMR, which means that we want our AMR more safety in the factory. Okay. All right. So what our solutions benefit about Swan autonomy? So just I mentioned Swan code. Swan code is kind of a software, and we provide Swan wrapper SDK or maybe Swan API. Try to make a third-party device, no matter OT or IT side. Okay, easy integrate. Just use one method for better development. And the second is the highly flexibility. Just as I said, the environment in factory is more complicated, right? So no matter which the factory you face up, the SMA has their own safety setup for the dynamic change and also the swarm code dispatching systems to face out maybe something happen in the room. Okay, so these things I try to make high OEE. So which we believe that from automatic to autonomy, so we try to make the machine can talk each other. You can reduce the labor time. Okay. All right. So this is a case in our factory. I just want to say we built in 1 week for the demo because the swarm code is quite easy. So the simple as we combine with the robot and the AMR and then the machine. So we just put that simply just 1 week to finish this scenario. Okay. Okay, so normally I would say a target market, but I put three optoelectronic, SMT, semiconductor. I think this is a target market for autonomy. Right now we have three kind of the AMR with the top module, and it's a project ongoing. So you can see for no matter different industry, our AMR can combine with the different top modules. Depends on the system integrator's know-how. Okay. Okay, now to give the very simple competitive analysis. Okay, here there's a brand end and a brand edge. Okay, brand edge you can see AMR AGV. Okay, in the past they use the QR code, maybe the guideline in the floor, but our AMR uses system technical, so they don't need to put everything on the floor. And the accuracy with the marker, I just mentioned that plus and minus 5 millimeter. And another thing is the classroom. Okay, because in the menu, I think, because we just got the class 1000 level in the last week. So this is the latest classroom level in our SMR. And I want to say that our MR have the private 5G. Okay, private 5G is another trend in the autonomy manufacturing smart factoring. So private 5G support, I think, is most important as well. Okay. All right, so just sum up what we provide. I just say we provide two payload, 250,000 PPTs, and 1,000 kilogram payload. And I will say with a lift, it's normally used with a rock. Without lift, normally with a robot or conveyor. Okay. I just recap what we are going to talk about the automatic to autonomy. So from automated machine is quite easy, everyone is doing that. But autonomy, we try to make our machine can talk each other to reduce the communication time, try to make information talk to each other in time and synchronously. So we provide the feature here, Swarm robot and Swarm code. Okay, and the Swarm code, I just say one UI, one method, try to make our user make easier to help them to transfer the type for automatic autonomy. And no matter the Swarm code, we have also have the docking performance, the parameter zone setup. We not only provide the software, we need to provide the XML as well. Because combined these two, we will just like have a more powerful performance for this solution. Okay, so benefits like we try to have a high efficiency, high precision, efficiency integrate here. Okay, I'm Alan. So thank you very much. I give you very quick rough introduce about the Swarm autonomy solution, and we give you our solution here. Thank you very much.
Welcome to Farabot's Swarm Autonomy Solution Global Debut at 2022 Automation Taipei Exhibition. Let's welcome our product manager and the live demo commentator, Bill.
Hello everyone.
Bill, there are many robotic solutions in the market. Can you explain why the industry still needs FA robot?
Indeed, there are many existing options, but they may only provide partial solution from software or device point of view. However, the biggest pain point from industry's perspective is the burdensome integration of infrastructure and automated processes. Farabot's solution simplifies the seamless integration and deployment of few to many devices to be coordinated and controlled to achieve agile collaboration of manufacturing resources. In the future, it is also expected to be introduced into Foxconn's Lighthouse Factory network to optimize the group's intelligent manufacturing systems.
Our demo illustrates how agile collaboration across IT, OT, IoT, and equipment helps to operate factories' end-to-end processes to achieve reliable automated operation in 24/7 autonomy. Let me briefly introduce our demo setup. There are 5 different devices from different brands running on the factory site. All of them are orchestrated by Farabot's Swarm Core, an unified software platform running on the back end. First is Farabot's Swarm Mobile Robot SMR250, the blue robot on the move. Second is our partner ABB's robot arm. Third is an industrial camera attached to the robot arm. Fourth and fifth are third-party AMR and AGV respectively. Here goes the demo. In this setup, we simulate an end-to-end automatic material handling processes at factory site. First, the orange robot carries an incoming cargo on a rack, while the SMR250 prepares an empty rack to receive the required materials. Both robots are heading towards the sorting spot, where the robot arm is located, to proceed with the material transfer. Bill, this process requires a complex infrastructure running behind the scene. It includes an ERP enterprise resource planning, a WMS inventory management, a MES manufacturing execution, and OT equipment such as robots, conveyors, and elevators. How can Swarm Autonomy help here?
The benefit is very straightforward. A fleet of robots from various brands is orchestrated by Farabot's Swarm Core platform to achieve agile collaboration. The back-end infrastructure is also integrated for better scalability and easier maintenance. New and legacy equipment can be connected to interoperate, achieving agile integrability.
As the robot arm reaches out to the incoming rack, it picks the right material and rotates 90 degrees to place it on the target rack on top of the SMR. Bill, can you explain more about how the heterogeneous robot collaboration works?
Originally, each equipment and system runs by its own communication protocol. Dozens of processes running concurrently means over hundreds of languages being spoken among robots and equipment, which is a huge problem. As an answer to this issue, FA Robot developed an interoperability protocol to unify robot and equipment collaboration. Swarm Wrapper is a protocol transition tool to create an homogenized and streamlined data highway that enables the swarm knowledge sharing from multi-brand systems and equipment to achieve a smooth coordination.
Now, the two robots dodge each other and rotate like performing duet dancing. This is the result of a meticulously engineered orchestration. Each robot's movement is part of a complex balance between performance, speed, and safety. It is a combination between technology and art. Bill, what's the next request for the robots?
The orange robot moves to the storage area to unload the remaining materials, whereas the SMR moves to the assembly area to continue the production procedure. Here it demonstrates how the Swarm Core can integrate systems and processes to generate a task schedule based on the predefined workflows. After a robot completes its task, it will seamlessly shift to the next tasks as scheduled.
Now another robot joins as the new task force while the SMR carries a WIP rack. Both robots will meet at the robot arm location. Bill, what do robots do with WIP?
The SMR is passing WIP to the gray robot for proceeding to the assembly at another floor. This illustrates how the Swarm Core provide benefit of agile operation by performing a smart matchmaking based on the robot capabilities. In this case, the gray robot is chosen based on its footprint, which fits the elevator size to reach another floor.
Now the robot arm passes the WIP to the gray robot, which will stay at a point for a while, symbolizing the operating time of running at another floor and getting back via the elevator. Bill, any key points to address in the meantime?
This is actually a fundamental innovation. In the past, it was required to specify robot and task types and constrain a single robot type for each task. Swarm Core, by contrast, dynamically matches the most suitable robot to each requested task depending on its requirements. This increases robot usage rate and enhances the workflow efficiency.
The gray robot just came back and coordinates its route with SMR. Bill, is this kind of route coordination a rare event within the factory?
This case illustrates a clear example of a factory with constrained and narrow space. This kind of environment usually creates robot traffic issues, while conventional solution wastes time by establishing a one-car-at-a-time policy. Swarm Core delivers an optimized intelligent traffic control thanks to DDS, Data Distribution Service, based low-latency peer-to-peer communication. One more thing, We just saw that the SMR started moving right after the gray robot departed from the elevator. Thanks to SwarmCore's agile optimization capability, it's possible to predict tasks' time span and schedules to achieve a synchronized robot arrival.
Now, the robot arm picks up the finished product from the gray robot and places it on the SMR's rack for outbound delivery. Bill, although the full detailed logistic process from inbound to outbound cannot be fully presented here, I realize that every step within this workflow requires a lot of collaboration across systems, sites, and equipment.
Yes, to overcome so many challenges across functions, SwarmCore firstly evaluates the environmental requirements to define the plan that can bring the most ROI as a swarm autonomy solution. For instance, SwarmCore can synchronize with the WMS request to adapt its operation. Through swarm knowledge sharing between robots and equipment, an accurate prediction of the requested task and located resources can be performed to activate the right tasks to the right robot, achieving an enhanced end-to-end efficiency and agile collaboration. This is the true value of swarm autonomy.
What does the robot do now?
It is returning to the charging station. As part of the agile optimization, charging tasks should be automatically dispatched during the idle time to ensure an optimum battery level for the upcoming tasks.
Here comes the end of Farabot's Swarm Autonomy live demo. Lastly, could you please introduce what kind of industries are suitable and perceivable to benefit of our solution?
All industries with intralogistics needs are suitable to adopt it, specifically, precision machinery, electronics manufacturing, warehousing, and logistics. To wrap up, there are 3 key values of SwarmCore. 1. Agile integration across IT and OT. 2. Agile operation across hybrid fleet. 3. Agile optimization at right time and right place.
Thank you for watching. Please go to our official site by scanning the QR code to find out more about Farabot's Swarm Autonomy solution and stay connected. See you soon.